Hi viewers, welcome to Learning Electrical Engineering channel. In this video we will see about how to solve the problem using superposition theorem. For that we have considered three different circuits which are shown in the screen. On the first circuit we are having two independent sources and one dependent source. In this circuit we need to find out the value of Vx. On the second circuit we are having three independent sources, and in this circuit we need to find out the value of current I which is flowing through the 3 ohm resistor. On the third circuit we are having three independent sources in which we need to find out the value of current I which is flowing through the 8 ohm resistor. But in this circuit a slight modification is given. So in this the voltage source is having 2 ohm internal resistance, and it can deliver up to 4 amps of, or we can say the source is capable to deliver 4 amps of current. Let us proceed with the first circuit. This In this circuit we need to follow certain steps for solving the superposition theorem. On the first step we need to consider only one source and to find out the value of Vx due to that independent source. And on the second step we need to turn on the another independent source, and we need to turn off all other sources, and we need to find out the value of Vx due to that particular active source. And in this manner we need to find out the value of Vx due to all dependent sources. Then we need to do the algebraic sum. And one more thing we need to keep in mind, that the voltage source, when we are turning off, it should be short circuited with its internal resistance. In case of current source we need to open circuit. On the first step we will proceed here. Step 1, in this we will turn off current source. We are going to turn off the current source. So when we turning off the current source, so the current source can be turned off like this. On the first step we need to turn off the current source. So step 1, turning off the current source. For turning off the current source we can just mark, we can erase like this and say this is open circuited, and Vx is the potential. Vx is the potential which we need to find it out. On turning off of the current source, we can write for identification purpose, we can write Vx is equal to Vx prime. Vx can be write Vx prime, and here also we can write 0.1 Vx is equal to 0.1 Vx prime. But for the calculation simplification purpose, we can write Vx prime divided by 10. Now in this circuit we need to find out the voltage across the 4 ohm resistor, that is equal to Vx prime. So in this we need to mark the currents. The amount of current delivered by the 10 volt source is I1. The amount of current delivered by the dependent current source is, let us say, I2, and the amount of current flowing through the 4 ohm resistor, let us say, I, and the potential at this point is Vx prime. Because this is one line, the potential in this line is always same, all the point is same. The potential in this line at all the points is same. Now we can apply the KCL. When we applying KCL, the algebraic sum of incoming currents is equal to algebraic sum of outgoing currents. In this, incoming currents are I1 and I2, the outgoing current is I. So we can write I1, this is the incoming current, I1 plus I2. which is equal to I. This is the outgoing current which is flowing through the 4 ohm resistor. To find out the value of individual current values, we need to apply the nodal analysis. To applying the nodal analysis, we need to mark the nodes. So let us start to mark the nodes. Let us say this is node 1, that is V1, and in this node we have already marked, that is Vx dash, and we need these two nodes, that is V1 and Vx dash are the non-reference nodes, and we need a reference node, that is V0, which is equal to 0 volt, that is ground potential. Now the value of I1 can be found. The I1 is the amount of current flowing through the 20 ohm resistor, and the potential is the difference of V1 and Vx dash. So we can write I1 is equal to V1 minus Vx dash divided by the resistance value is 20 ohm. As per Ohm's law, we can write I equal to V by R. Now in this point we know that the source potential positive terminal is connected with the 20 ohm resistor, and if this point is we have marked as V1, that is the non-reference node. So V1 we can write V1 is at a potential of 10 volt. Okay, now plus I2. I2 is the amount of current delivered by the dependent current source. So we can write I2 is equal to Vx dash divided by 10, which is equal to the amount of current flowing through the 4 ohm resistor is equal to the potential difference is Vx dash, Vx prime minus V0. So V0 equal to 0 volt. So we can eliminate in the next step. Vx prime minus V0 divided by the resistance value is 4 ohm. Now we need to solve this equation to find out the value of Vx prime when the 10 volt source is active. So we know that V1 is equal to 10 volt. We will apply here. So the value will become 10 divided by 20 minus Vx prime plus Vx prime by 10 is equal to, we know that V0 is equal to 0, so we can eliminate it. So Vx prime by 4. Now on further simplification, the equation will become 10 minus Vx prime plus 2Vx prime divided by 20, which is equal to Vx prime by 4. Now we can multiply the numerator and denominator of right hand side of this equation by 5. So we can get 10 minus Vx prime plus 2Vx prime will become plus Vx prime divided by 20 is equal to 5Vx prime divided by 20. So on further simplification of this equation, we can write Vx prime is equal to 10 plus Vx prime is equal to 5 Vx prime. As the denominator terms is equal, it can get cancelled. So finally the Vx prime is equal to, correction, the positive Vx prime on the left hand side, when we transferring to the right hand side of this equation, it will become negative term of Vx prime. So the total value is 5 Vx prime minus Vx prime will become 4 Vx prime, which is equal to 10, and Vx prime is equal to 2.5 volt. So we can mark this 2.5 volt when the voltage source is in active. Next, on step 2, we need to turn off the voltage source and we need to active the current source. Let us do that. Now, in this we need to turn off the voltage source by short circuiting it. we will short circuit it now. We have short circuited the voltage source with its internal resistance. As internal resistance is not mentioned, we have directly short circuited by assuming the zero resistance, and the current source is active and dependent source is available. Now we need to solve the circuit. Now as step 2, turning off of voltage source. Of voltage source. We have turned off the voltage source by short circuiting it. Now we need to find out the values of voltage Vx. For identification purpose, we can write Vx will be Vx double prime, and here also Vx double prime for the dependent source. Now for calculation simplicity, we can write Vx double prime by 10, the value of dependent source. Now for solving of this circuit, we need to mark the currents, because we need to find out the voltage across the 4 ohm resistor. So this will become this is equal to Vx double prime. So for find out the voltage across the 4 ohm resistor, we need to mark the currents. So the currents, the 2 amp current is I1, and the dependent current source will deliver a current of I2, and outgoing currents is, let us say this is I3, and the current flowing through the I4 ohm resistor will be I4. Now as per KCL, we can write the algebraic sum of incoming currents is equal to algebraic sum of outgoing currents. So in this, the incoming currents to this node is, in this junction is I1 plus I2, and the outgoing currents are I3 and I4. We can write this is equal to I3 plus I4. Now in this circuit, we know the I1 is equal to 2 amps. So I1 is equal to 2 amps, we can write here. So directly now we need to apply the nodal analysis to this circuit. So for applying of the nodal analysis, we need to mark the reference and non-reference nodes. As the reference node, we can mark V0, which is equal to 0 volt, that is in ground potential, and here only one node is available, that is Vx double prime. So now we can start to apply the values, or start to find out the values of I2, I3 and I4, and we will apply in the KCL equation. So the I1 is equal to, we have already told here, is equal to 2 amps, and I2 is equal to the amount of current delivered by the dependent current source is Vx double prime by 10, which is equal to I3. I3 is the current flowing through the 20 ohm resistor. So that is the potential difference between the 20 ohm resistor is Vx double prime minus V0, Vx double prime minus V0 divided by 20. This is the resistance value. And I4 is the, here also the same potential is available. So the potential difference is Vx double prime minus Vx double prime minus V0. The resistance is 4 ohm, so we can write it here. Now on solving this equation, we will get the value of Vx double prime, and we, on the next step, we need to eliminate the V0 value, that is equal to 0. We need to eliminate it. So the equation will become 20 plus Vx double prime by 10, which is equal to Vx double prime by 20 plus Vx double prime by 4. On simplifying the equation, it will become 20 plus Vx double prime by 10 is equal to Vx double prime plus 5Vx double prime divided by 20. Now we can transfer the value of 10 to the right hand side of this equation. So the equation will become Vx 6Vx double prime divided by 2, okay, which is equal to 20 plus Vx double prime. Fine. Next we can simplify this equation as correction. So the value will be 3Vx double prime. When we transferring the Vx double prime to the right hand side of this equation, it will become the negative Vx double prime. So 3Vx double prime minus negative Vx double prime will become 2Vx double prime, which is equal to 20. Now Vx double prime, you can say that, which is equal to 10. Now this is the voltage Vx double Vx when the current source is active. Now we need to do the algebraic sum when the current source is active and when the voltage source is active. Now let us proceed with the first circuit. In this circuit, when we see when the voltage source is active, that time Vx prime is equal to 2.5 volt with voltage source, and Vx double prime is equal to 10 volt when with current source. Now when we do the algebraic sum, both the values are positive, so the total value of Vx is equal to 12.5 volt, which is equal to 12.5 volt. So this is how we can find out the Vx value by using superposition theorem. If n number of independent sources are available, we need to continue with each individual independent sources, and finally we need to do the algebraic sum to find out the value of Vx. Next we will consider this circuit and we will find out the value of current I, which is flowing through the 3 ohm resistor. For this, this is the circuit. In this we are having 3 independent sources, in which 2 are the voltage sources, 1 is the current source. For circuit solving using superposition theorem, we need to follow the same steps which we were done in earlier problem solving. First we will consider the 12 volt circuit and we will turn off the 24 volt and the 3 amp current source. For that we need to short circuit the 24 volt voltage source with its internal resistance. As internal resistance is not shown here, we will consider that it is 0, so we will directly short circuit it and we will open circuit the current source. This is step 1. 12 volt source is active. In this 12 volt source, when the 12 volt source is active, that time the resistance 8 ohm and 4 ohm is in series, so we can write it as 12 ohm, and then this is 12 ohm, and further 3 ohm is in series with this, so 3 ohm, and a 4 ohm resistor which is in parallel with the 12 ohm resistor, so This is the source plus minus 12 volt, and this is connected here, and this terminal is further connected with this, and a 4 ohm resistor is connected with the 12 ohm resistor. So this is considered, this is 4 ohm. Now when we further simplifying this circuit, and the 12 ohm and 4 ohm resistor are in parallel, so when we solving this, the for formula for solving the parallel resistors, RT is equal to R1 into R2 divided by R1 plus R2. In other words, the multiplication of these two resistors is divided by summation of these two resistors. So when we doing it, we will get a value of RT is equal to 12 into 4 divided by 12 plus 4, that is 16, which is 48 divided by 16. Okay, now 3 ohm will be the equivalent resistance of this circuit. So on further simplification, we can write 12 volt source, that is plus minus, and this value is become 3 ohm, and one more 3 ohm resistor is available. The current flowing through this is I prime. As initially we should consider the value of I, which is flowing through the 3 ohm. When the 12 volt source is active, we can write it as I prime, and the circuit is get completed. The amount of current which is flowing through this circuit or the 3 ohm resistor is I is equal to V by R. V in this circuit is 12 volt, and resistance 3 ohm resistors are connected in series, so the equivalent resistance will be 6, and the current will be I prime is equal to 2 amps. Fine. On when the 12 volt source is active, the current flowing through the 3 ohm resistor I prime is 2 amps. Next, we will consider the 24 volt source is active, and the 12 volt source is short circuited, and 3 amps current source is open circuited. Now we will short circuit the 12 volt source and open circuit the current source. Fine. Now we will short circuit it, and this is open circuited. Now only the 24 volt source is active. When the 24 volt source is active, now we need to find out the value of current flowing through the resistor of 3 ohm. Let us now mark this is I double prime, as now this is the step 2. Step 2, 24 volt source is active. Yeah, turn down. We can write. Now when we see in this circuit, still this 8 ohm and 4 ohm is in series, and we can further simplify this by using the mesh analysis. So on mesh analysis, we can form the two equations. Okay, now we will mark the currents, the loop currents, that is, and this is, say this is I1, and this is open circuit, there will not be any current, and say this is I2, and we know that the I2 is equal to I double prime. Okay, and now we will start to write the equations for loop 1 and loop 2. So for the loop 1, when we applying the KVL in this circuit, we can write 8 plus 4, the resistors are in series, 8 plus 4 12 plus 4 16 I1. Okay, and finally meeting the positive potential of 24 volt, so we can write 24. Now the 4 ohm resistor is in having the effect of I2 also, so we can write I2, that is if it is in opposite direction, I2 is in opposite direction of I1, so we can write negative 4 I2 which is equal to 0. Fine. On simplification, the 24 value, numerical value, can be transferred into the right hand side of this equation, and this equation will become 16I1 plus, correction, minus 4I2 which is equal to minus 24. Now the equation can be divided by 4 on both sides of this equation, so the equation will become 4I1 minus I2 is equal to minus 6. Let's say this is equation number 1. Fine. When we applying the KVL to the KVL, when we applying the KVL to the loop 2, this is loop 1 and this is loop 2. In this loop, we can write 4 plus 3, 7 I2, and the 4 ohm resistor is having effect of I1 also, and the direction of current is opposite, so we can write 4 minus 4 I1 which is equal to 0. Now let us say this is equation number 2. Now I want to find out the value of I2 which is equal to I2 double dash. So I want the value of I2, so we can add these two equations. When we adding the equation 1 plus 2, the 4I1 minus 4I1 will get cancelled out, and the 7I2 minus I2 will be 6I2. Okay, and when we adding this, which is equal to minus 6 plus 0, minus 6 minus 0 will be minus 6, so I2 is equal to minus 1, and we can say that I double prime, when the 24 volt source is active, the current flowing through the 3 ohm resistor is negative 1. Fine. Next we will proceed to step 3. We will write it here, I double prime is equal to negative 1. Same manner we can write here, I prime is equal to 2 amps when the 12 volt source is active. Next we will consider the turn on the 3 amps current source, and we will turn off the both the voltage sources. As the internal resistance is not shown here, we will turn off these voltage sources with short circuit. Okay, let us do the short circuit. We did the we have short circuited. Now we need to apply the in this step we need to find out the value of current I when the current source of 3 amps is active. So for this, let us mark this I triple prime, and we need to mark the currents to apply the KVL. So correction, we apply the KCL. So the current source deliver the current, this is say I1, and it is flowing through the when it is flowing through 4 ohm, it will become I2, let us say, and let us say this is current flowing through 8 ohm is I3, and we need to find out the value of current which is flowing through the 3 ohm resistor. For that we need to mark the currents. Okay, now if in this point, when we applying the nodal analysis, let us say, or first we will apply the KCL. For KCL, at this junction we can write the algebraic sum of incoming currents is equal to algebraic sum of outgoing current. The incoming current is let us say this is I1 and the outgoing currents are I2 plus I3. Fine. Now what we need to do, we need to find out the value of currents I1, I2, I3 individually. As we know that I1 is equal to 3 amps, we can write I1 is equal to 3, and I2, we need to find out the value of I2. For find out the value of I2, we need to mark the nodes, and we need to find out the currents of I2 using nodal analysis. When we marking the nodes, let us say this is V1, this is V2. Okay, and the reference, these two nodes are non-reference nodes, and the reference node is this V0, which is equal to 0. Fine. The amount of current I2 is flowing through the 4 ohm resistor, and the potential difference is V1 minus V2. Let us write I2 is equal to V1, correction, V1 minus V2 divided by the resistance value is 4. Fine. For I3, the potential difference is V1 and the reference node is V0. So we can write V1 minus V0 and the resistance is 8 ohm. Now when we solving this equation, on the next step we will write V0 is equal to 0. So it will become 3 is equal to V1 by 4 minus V2 by 4 plus V1 by 8. Now on further simplification of this equation, that it will become 3 is equal to 3V1 by 8 minus V2 by 4. Now this equation further we can simplify it. 3V1 minus 2V2 by 8, which is equal to 3, and we can write 3V1 minus 2V2 is equal to 24. Let us say this is equation number 1. Now I am interested in find out the value of current flowing through the 3 ohm resistor. For that we need to mark certain current. This is the incoming current is I2 and the outgoing currents are, let us say this is I4 and this is I5, here this is I2. Now when we applying the KCL to this junction, we can write the incoming currents I2 is equal to outgoing currents I4 plus I5. We know that I4 is equal to I triple prime, and we will mark it here. I4 is equal to I triple prime. The I triple prime indicates that when the current source is active, the amount of current flowing through the 3 ohm resistor. Fine. Now here also we will apply the nodal analysis to find out the value of I2, I4 and I5. The value of I2 is equal to, we know that we have already seen here, the potential difference is V1 minus V2, V1 minus V2 divided by the resistance is 4 ohm, which is equal to I4. I4 is equal to V2 minus V0, which is equal to 0. So we will write V2 divided by V2 minus V0 divided by 3 and plus I5. When we seeing this I5, the potential difference is V2 minus V0, V2 minus V0 divided by the resistance is 4 ohm. Now on solving this equation, we can find that this will become V2 by 3 plus V2 by 4, here V1 by 4 minus V2 by 4. Now when we transferring this term negative minus V2 by 4 to right hand side of this equation, it will become V1 by 4 is equal to V2 by 3 plus 2V2 by 4 will be V2 by 2. V2 by 2. On further simplification of this equation, it will become 5v2 divided by 6 and v1 by 4. Fine. Now we need to find out the value of v2 and we can apply further into this equation number 1 to find out the value of v1. For this, v1 is equal to 20 v2 by 6, which is equal to 10 divided by 3 into v2. Now we will apply this value of v1 into the equation 1 so that we can get the value. So let us say this is equation 2. From this equation 2, apply equation 2 in equation 1. So the 3v1 v in place of v1 we can write 10 by 3 into v2 minus 2v2 is equal to 24. On simplifying this will become 10v2 minus 2v2 will be 8v2 is equal to 24 and v2 is equal to 3 volt. Now we have found the value of v2. Now we will apply this v2 here and we will find out the value of current I triple prime. So I triple prime, that is I4 is equal to I triple prime is equal to v2 by 3, which is equal to v2 is how much? 3 by 3, which is equal to 1 amps. Okay. Now the I triple prime, when the current source is active, that time it will become 1 amps. Now we will do the algebraic sum. Next step we'll do the algebraic sum. Okay. In this circuit we will see when 12 volt is active, the current is 2 amps. Let us recheck once. When the 12 volt is active, the current is 2 amps. When 24 volt is active, the current is minus 1 ohm. Minus 1 amp. When 12 volt is active, the current is 2 amps. When 24 volt is active, the current is minus 1 amp. When 3 amp is current source is active, that time the current is 1 amp. So when we doing the algebraic sum, the current flowing through the 3 ohm resistor when all the sources are active, which is equal to 2 amp. So the current flowing through 3 ohm resistor is 2 minus 1 plus 1, which is equal to 2 amps. This is how we can find out the value of current through the any value of resistor or any element using the superposition theorem. Next we will solve the another circuit, that is this circuit. We will solve the circuit and we will find out the value of I using the superposition theorem. As we know that we need to apply the steps. On the first step we need to turn off one voltage source and we need to turn on one voltage source. Rest all the sources, independent sources, are to be turned off. On the first step we will consider the 16 volt source and rest we will do the turn off. the current source can be turned off by open circuiting it, and voltage source can be turned off by short circuiting it. Okay, we will do the short circuit. We done the short circuit, we done the open circuit. Now on this step, as a step 1, 16-volt source is active, rest are turned off. In this, now we need to find out the value of current as I prime. When the 16-volt source is active, we need to find out the value of current. We can simply find out by I is equal to V by R, and voltage is 16, and the resistance in the circuit will be 6 to 8 plus 8, 16, which is equal to 1 amp. Then I prime is equal to 1 amp. Fine. At the next step, we will consider it here. As a step 2, step 2, 12-volt source is active. When 12-volt source is active, we need to turn off the current source and the voltage sources. We will turn off the current source, can be turned off by open circuiting it, and voltage source can be turned off by short circuiting. We will short circuit it. Now the current flowing through the 8 ohm resistor will be I double prime. So the amount of current, which is I is equal to I double prime is equal to V by R, that is 12 divided by total resistance will be 16. Correct? When we solving this, 3 by 4, which is equal to 0.75 amp. Fine. On next step, we will turn off both the voltage sources and we will activate the current source. In this step, we will activate the current source. We have short circuited both the voltage sources and current source is considered. Now we can replace this circuit by redrawing it. So here the voltage source is given indirectly. So how can we do that? The first 6 ohm resistor is here, and here we can replace it with the value of 8 volt current voltage source which is having the internal resistance of 2 ohm, and further the 8 ohm resistor is available and we can connect it. Now we need to find out the value of current, that is I. In this case we can say I triple prime. Fine. I triple prime. When we seeing this circuit, I triple prime can be calculated as I triple prime is equal to V by R. V is equal to what? 8 divided by R is 6 plus 2, 8 plus 8, 16. Fine. The value of I triple prime will be 0.5 amp. Now we can calculate the value of I by doing the algebraic sum of individual source fx. So I is equal to I prime plus I double prime plus I triple prime. Now I is equal to I prime, the value is 1 amps, and I double prime is equal to 1 amps, which is in opposite direction, because the I we have shown here in this direction, that is towards 12 volt source, but actually the current will flow in the reverse direction, so we need to take it as minus 0.75, and the current which is delivered by the voltage source, that is I triple prime, which is equal to 0.5 amps. So the total current delivered or the total current passing through 8 ohm resistance when all the sources are connected is 0.75 amps. In this manner we can calculate the total current flowing through the 8 ohm resistor using the superposition theorem. I hope the viewer would have been understood the application of superposition theorem and how to solve these circuits. If you have any doubt, kindly write it on the comment box. I will reply. And if you have not subscribed my channel, kindly subscribe it. If you have liked my channel, kindly hit the like button below this video. Thank you so much.